we on now? 6? Here, thanks for the heads up. Okay, so number 1, remember these limit problems, these can add up in a hurry. So the first one is F. We got, no! I'm gonna hurt someone. Okay, it started with this. This is the first one, the first day. What is the limit of this one? 0. Why? Because the top always stays between -1 and 1, and then you keep on dividing by bigger and bigger numbers, right? Like fraction over a million, fraction over a billion, fraction over a trillion. In other words, the graph is oscillating, but since you keep dividing it by bigger and bigger numbers, it gets closer and closer to 0. Then the next day, I gave you this one. How come that limit is 0 also? Because the top stays between -1 and 1, sine and cosine, same thing, right? And then you just keep dividing by bigger and bigger numbers. So it's oscillating, except it's getting closer and closer to 0. So that limit. And then yesterday we had this one. It's the same thing, people. This number stays between 0 and 1, and then you keep dividing by bigger and bigger numbers. It's getting closer to 0. And then today, I give you this one. It's the same thing. It stays between 0 and 1, and the bottom keep dividing by bigger numbers. It's 0. I just change it a little bit, and all hell breaks loose. There's going to be a lot of hell breaking loose tomorrow then. Natural log of the nth root of 3. Now, why don't we rewrite it? What does nth root mean? Doesn't that mean 1 over n power? And then what? What can you do with the power if it's a logarithm? Put it in the front. So isn't that the same thing as natural log 3 over n? So the top is just a number, which is 1 point something, right? Natural log 3 is 1 point something, right? And you keep dividing it by bigger and bigger numbers. 1.1 over a million, 1.1 over a billion, 1.1 over a trillion. These numbers are getting closer to 0. If you look at something that looks crazy, why not just simplify it? And then J. Lomi, Lomi! Okay, now, please do not do this. I keep telling you guys this, but somebody's going to do it tomorrow. What's the limit of the thing in the parentheses? You gotta be joking. What? The thing in the parentheses? Are you joking me? It's 1. How come? Because what's the limit of just that thing? If the degree of the bottom is bigger than the top. It's 0. What's 1 minus 0? 1. So this thing gets closer and closer to 1. And what's natural log 1? 0. Also, 0 times anything is 0. No, because that thing is going to infinity. Infinity is not a number. You cannot treat it like a number. I keep telling you guys that. So you cannot go, oh, that's 0, because it's not anyway. So what do? When you have a logarithm, what can you do with this thing in the front? Put it up as the power, and then maybe if you write it like this, hey, you somebody, 1 plus box over n to the n. What's the limit of that? E to the box, which is e to the negative 1. That's the limit. So that part there is getting closer and closer to e to the negative 1. And then you got a natural log it. So the whole thing is getting closer to natural log of e to the negative 1, which is... Okay, let's go back to when we studied
Negative 1.
Too late. What is the natural log of e to the gorilla? Gorilla! So negative 1 is the answer. How can we not know natural log? Just like e to the natural log banana is banana. They're inverses of each other. You plug one into the other, you get x. Oh my lord. Not a hell breaking loose. Is that an L I see up there? Or is that an I? Next to the N. If that indeed is an N. Okay, why don't I just go over there? Thank you for telling me. This is an N. What is that? Is that an I, L, what? That's a comma. That's not a comma. I'll give you a comma. It's not a comma.
Looks like an eye. Maybe it's both.
It's an I and an L.
A 1.
Quinto,
I have
Looks
no
like an
idea
eye.
what it.
who wrote this?
Looks like an eye.
Yeah, I think it's an eye.
Then how come you
Little
didn't put
dot.
it before the J? Look, this person put the G in that.
I think the eye was there first, then.
And then someone erased the dot.
Are you joking me?
Small little.
Okay, I then. Secant inverse n. Just know what the graph looks like, people. This is a base graph. Hello. Secant inverse, hump right, hump left. Okay, here's the graph. Now, of course, if I draw the graph for you, everybody can get it. As the graph goes out to the right, the y coordinates are getting closer and closer to y over 2. That's the limit. See, the problem is you don't know your base graph, so that's the problem. How about just look it up on, didn't I give you a page that has all the base graphs on it?
Yes.
Okay. And, are you sure? People, E is like 2.7 and the bottom is getting bigger and bigger and bigger. Right? Natural log goes to infinity, right? Very slowly, but it does. So 2.7 over a million, 2.7 over a billion, 2.7 over a trillion.
It's getting smaller.
Yeah, it's getting closer to 0. Can't believe we did that one. And then everybody could do the factorial then. Garen's Barron's gonna have a couple of these now. So you guys just simplify it, right?
Yes.
So did you guys simplify it? Yes or no? Now is the time to ask.
Let me do all.
Oh. N plus 1 factorial, 2n factorial. Okay, when you see the factorial one tomorrow, you simplify it. If you simplify it, the answer will be right there in front of you. Okay, let's do this first. How do you simplify n plus 1 factorial over n factorial? That's what? N plus 1 on the top, right? Because all the other stuff cancels out. What? And same thing with this right there. There's n plus 1 on the top. Now what about this and that? Yeah, you're going to have 2n plus 2 times 2n plus 1. And then starting from there, everything else just cancels, right? That's what's left. How do we find the limit of that? If the degree of, this is the easiest one. If the degree of the top and the bottom are the same, just look at the coefficients. 1/4 is the limit. Huh? Well, if you multiply out the top, you get n squared plus 2n plus 1. If you multiply out the bottom, you get 4n squared plus 6n plus 2. If the degree of the top and the bottom are the same, look at the coefficients. How many of these you think you can see tomorrow where you just compare the degree of the top and the bottom? No, I'd say about 3 or 4. But they're going to be like within a problem like L. See how, look in the parentheses, the degree of the top and the bottom are the same? What's the limit of that? 1/2, but then sine inverse 1/2, see? Gets kicked up a notch. Okay, and then we move on to, you guys better review your base graphs because you got to know them. 2 chapters from now, it's the same thing. You don't know your base graphs, you'll be crying. Weeping. You go to 4A and 5C. 4A. Oh, here's a good one. Only A? Wow, that's very interesting. Okay. 1, 5, 1, 5, 1, 5. Now, if you look at the answer on the bottom, it kind of tells you like what you need to do, right? Like, do we know of any sequence? Look, 1, 5, it just goes back and forth. 1, 5, 1, 5. Do we know of any sequence that does that? Goes back and forth between 2 numbers? Yeah, but I'm thinking of something even easier. How about -1 to the n? Doesn't that just go -1, 1, -1, 1, -1, 1? Just goes back and forth between two. Yeah, but Mr. Park, this is 1, 5, 1, 5. No, it's the same thing, just translate it. What's the distance between -1 and 1?
2.
But this one is 4. So you just multiply it by 2, and so you're going to get -2, 2, -2, 2.
Hey.
So now the distance between them is 4. All you got to do is what? Shift it up 3 now. Add 3. So if you add 3 to each one, you get 1, 5, 1, 5. You got to go back to something you know. I don't know anything. Okay, and then here we go, 5, which one? 5C. That is so strange. Isn't that the easier one?
Yes.
5B is the harder one. But no, this is period 3. Okay, so in C, you gotta fill in the box, just like tomorrow. Just have the box.
There's no.
Except now, it's multiplication, so this is what you need to do. A2 equal A1 times something. A3 equal A. How many of these do I do tomorrow, Mr. Park?
4
Otherwise?
minus triple.
Okay, see? You guys know what's happening. Okay, fill in the box. What do I have to multiply this by to get that? Yoshino. You got the easy one because it's 1. Fill in this first parentheses. -1/3. Cito. Next one. What do I need to multiply that by to get that? Here. No. What do I multiply that by to get 1/5? -3/5. Zhang.
5, 7.
Huh? 5 7?
There you go.
And then Miyaoka.
No, -7.
Is there a pattern to that? Or these are just random numbers. There's a pattern! So the first thing you notice, they're all negative. You get 2 points for that negative right there. Who said yeah? And then look at the top numbers. 1, 3, 5, 7, 8. That's arithmetic. Common difference 2. So you write 2 in and then adjust. If you plug in 2, you want to get 1. So -3. And look at the bottom numbers. 3, 5, 7, 9. Hey, that's arithmetic. Common difference 2. So 2 in, adjust. If you plug in 2, you want to get 3. -1, and there you go. I believe tomorrow's one is not quite that simple. You're going to have to kick it up a notch. I think the +1 is a harder one. No time on the big burger. Do we need to do it? So Guido just takes the hit all the time for the class. Oh, why did I erase the thing? That's okay, you guys are just gonna read it off your paper, right? So this is what you need to do. A1 plus something. How many of these again? At least 4 tomorrow. Oh, this is a 4. Okay, fill in. Oyanomari, first one. Just read it off your paper.
-4/3.
What? Negative
4/3.
-4/3. Guido?
-8/15.
Mm-mm.
Oh. 8/15.
8/15. Next, who's next? Chen?
-12/3.
Mm-hmm. And the next one, Chai? 15. Okay. So now we just generalize. Equal a(n minus 1) plus box. Okay, now the first thing I notice, it's going negative, positive, negative, positive. How do you make it alternate? It's either gonna be -1 to the n or -1 to the n plus 1. If you plug in 2, you want it to come out negative. N plus 1, you just got 2 points right there. Now look at the top numbers. 4, 8, 12, 16, and that's arithmetic. What's the common difference? 4, so you write 4n and then you adjust. If you plug in 2, you want to get 4. Okay, so you guys can do it. Now the bottom numbers are not arithmetic or geometric, so you gotta break it down or look at the differences or whatever. You gotta do something. But come on, how many times have we done this? 1 times 3, 3 times 5, 5 times 7. Some of you have yet to do it though. 7 times 9. Look at the first numbers. 1, 3, 5, 7. Hey, common difference too. 2n and then adjust. What? And then look at the second numbers. 3, 5, 7, 9. Common difference too. 2n and adjust. Or, Chai likes to think like this, like yesterday. Hey, that's 2 squared minus 1. That's 4 squared minus 1. That's 6 squared minus 1. That's 8 squared minus 1. Did you do that this time? Yeah. That works too, right? So how do you generate the numbers 2, 4, 6, 8? Just tell me. How do you generate 2, 4, 6, 8? The common difference is 2, and then adjust. If you plug in 2, you want to get 2. Minus 2, and then minus 1. But when you multiply it all out, isn't that the same thing as this? Yes. So either way, works. Can we repeat that tomorrow? Yeah.
We'll get credit for setting up with the box.
Just for drawing the box?
No, like setting the whole thing up with the
Oh,
box.
you mean drawing these things?
Yeah.
No, if you just don't, it's just that if you don't, you can get minus triple.
No, but like, say we can't break it down, like tomorrow on the test, and we just have the setup with all the differences and the box.
Okay, this is how it's gonna go. It's gonna be probably 2 points for this, 2 points for that, because it's easy, right? And then 4 points for this part there. That's what it's probably gonna work.
So no credit for just drawing it out.
You get, that's where all the free points come in.
Okay. Oh yeah.
And then what, again, just to remind you, what did I say the last problem on the test is?
Oh, the coin
See,
toss.
that-
Oh no, that was last.
I'm not even doing probability. What did I say multiple times is gonna be the last
wait.
problem on the test? How many times I told you?
Linear recursion.
Linear recursion. Now, I believe, I made the test this morning. I even put parentheses. This is linear recursion. If you still miss it, I can't help you. I can't help you. Okay, are we done? So even though you didn't know, I tell you, this is linear recursion. That's kind of, you guys like that? You like being spoon-fed? You like the bib being put on? You like your diaper being changed?